Yes. Yeah.
Would you like to leave?
All right, so here we go. We've got example 6. This is like the first example we did yesterday. These should be the substitution problems that you guys look for. You want these. These should be kind of our favorite ones to go interact with. When they both have y solved for, okay? They both have y solved for. The idea is that when these things cross, these are two lines, the place where they cross, the x's and the y's are identical, right? Okay? So this y value and that y value should be the same. And the thing that creates that top y value is negative 3x plus 1. Does that make sense? The thing that creates the bottom y value is negative x plus 9. Now, if where these cross, if these two y values are the same, then the values or the expressions that created them have to also be the same. Does that make sense? Yes. Okay. So the hope is that we see that when they're both solved for y, all you have to do is you take that amount, because it's saying y is that amount, right? And you come down to this equation where you see y, and you replace it with negative 3x plus 1. Okay, so when we do that, I'm going to get negative 3x plus 1 equals negative x plus 9. This says y is equal to negative 3x plus 1, so I come down here where I see y, I interchange those, I replace them, right? That's the substitution. Does that make sense? Okay. Now here's my argument. We had this discussion last period. If we go through all of our algebra and all of our courses in high school, every new topic is taking old topics and just kind of building maybe one step on top of them, or taking like 2 or 3 old topics and merging those together and getting this new process. This is a bunch of old topics, substitution and solving equations, okay, one variable equations, that are tying in together to create this process. Does that make sense? Yeah. The first step where we highlighted stuff in showing how we're going to replace, that's the substitution that we learned in chapter 2. And then solving this is the substitution, the solving of equations that we learned inside chapter 2 and 3. Okay? So once we get to this stage here, do we have an equation that we're able to solve? Yeah. Okay, so what are you going to do first to solve this equation? Say again? Combine like terms. Okay, so I'm going to look at this side. Are there any like terms on this side? No. Nope. Are there any on this side? No. So that's done. Now we have to, since we got x's on both sides, right? We want to get all our x's on one side and everything else on the other side, right? Okay. So you're going to add 3x. Could I have added x? Does it matter?
No, it doesn't matter.
It shouldn't matter. Okay. So there, those are going to cancel. Leaves me 1 on the left. And you have 2x plus 9 on the right, correct? Remember our overall process here. We want all our variables on one side. Did that get all our variables on one side? And then everything else needs to be on the other side, right? So I need to subtract 9. So now I get negative 8 is equal to 2x, right? So now what do you do? Divide by 2. I get negative 4 is equal to x, right? Okay. My hope is that you realize that after you create that black equation, everything that we did was something that we've already done. You've already shown and demonstrated your proficiency on that on tests and quizzes and other chapters, right? Okay. That kind of stuff's not going to go away. And that's kind of open your eyes to when we learn something in algebra, you can't just forget it. Like maybe you learn, stuff about like DNA and science, and the next chapter you can forget it because you're going to talk about maybe the water cycle or something, okay? In math, you can't do that, okay? It stinks, but it's just the way it is. So now that I know what x is, can I come back up to these two equations and plug x in either right there or right there, and will that tell me what y is? That make sense? I always ask the question, which equation is going to be easier to plug into? Which equation up there looks simplest? First one, okay. There's no wrong answer to that. Okay, you might think something looks simpler than somebody else does. But if I go to the first one, I just plug in x as -4. So I got -3 times -4 plus 1. What's -3 times -4? 12. 12 plus 1? 13. So that's telling me y is 13, right? So x was -4. So that's my x coordinate in my ordered pair. Y is 13, and that's how we write our solution. Okay. Now, I asked you to plug it into what you thought to be the easiest. Some of you might have thought this would have been the easiest. If I go y equals, there's a minus sign there. Now, x, we said was -4, and then add 9 to it. What's the opposite of -4? 4 plus 9 would be 13. It's the same result, regardless of what equation you plug back into, right?
Yeah.
So the whole grand scheme of things, what we're going to try to do is initially make a substitution so that we get an equation where only one variable is left over. Okay? Either x's or y's. Solve for that variable. Once you find the numerical result for that variable, you then go back to one of your original equations and substitute into one of your original equations and solve for the other variable. Okay? Like I said, that setup of equations is what we're going to hopefully look for. And when we get a question that is like that, we should be thankful for it because it's the easiest version. Okay. Now, everything that we do can be done that way. Okay. So every question you come across, I'm going to do example 5 here. Every question we've come across, we look at 3x plus 4y equals 7. That's not in y equals mx plus b form, right? If you want to change it, you can. And so you have two equations that y is solved for in both of them, right? And then follow through with what we just did in that example 6. But there's easier ways. There's more efficient ways. Okay? We just got to be able to recognize this. When we see it, this says y equals, okay? That is saying y is x plus 3. Good. Okay? So, if this equation already has y solved for, can I come down to the other equation, and wherever I see y, replace it with what it is? And the top equation is telling us what it is, right? So I'm going to come down here in this bottom equation. I'm going to rewrite the bottom equation as 3x plus 4. Now the y turns into what? X plus 3. The only thing that I want to caution you on, and we said this earlier in the year, so this should be just a reminder, when you substitute into another equation or another expression, always put what you're substituting in parentheses. Okay? Sometimes you need them, sometimes you don't. But if you've got them and they're extra, they won't hurt. Does that make sense? But if you don't have them and they're needed, it will hurt. Okay? So if you always put parentheses around what you're substituting in, you're going to be doing a safe practice that will always provide you the correct process next. What is this telling me I have to do right here? Distribute. So I'm going to get 3x plus 4x plus 12 is equal to 7. You guys agree with that? That's what I get when I distribute that 4. Now what are you going to do?
Combine like terms.
Combine like terms, so 7x's plus 12 equals 7. Now what?
Minus 12, I don't know what 7 is.
-5, good. And now what? Divide by 7. So
Negative 5
-5/7.
sevenths.
And we leave it that way. Okay. Now here's where these can kind of get messy. We start with really nice whole numbers in the problem, but we go through the math and we get a nasty answer, right? Fraction. We're going to leave it as a fraction, and we're going to substitute. And this is where deciding which equation looks the easiest is going to help us, even though we've got kind of nasty numbers here. Is that equation or that one? Which one looks easier or simpler? First one, right? Okay. So that's where I'm going to replace this x. I'm going to take that x right there and put it right there. Does that make sense? So then I will write negative 5/7 plus 3 is equal to y. The reason that top one is, and I'm using that logic of it looks simpler, is because now all I have to do is add negative 5/7 and 3 and I've got my y, right?
What is it?
16/7.
Okay.
If I go to the bottom blue one and I plug in x to be negative 5/7, I need to multiply that by 3. And then I need to subtract that from both sides. And then I need to divide by 4 to get y by itself. Does that make sense? There's a lot of algebra plugging it into that bottom one. I don't want to have to mess with. Okay? So, what do I need? If I'm going to add these together, and I'll show you how to do this with your calculator in a moment. But if I'm going to add these together, what do I need? If there are two fractions like this. Don't they both have the same denominator? Okay, so I need a common denominator. So how do I, and we use multiplication, so what do I need to multiply 1 by so that I get this 7? 7. So what do I, now if I change that bottom to 7 but I keep the top 3, 3/7 is different than 1, or than 3, right? So what do I need to multiply the top by? 7 as well. And the idea there is that 21 over 7, we basically undo a simplified fraction, right? 21/7, is that still 3?
Yeah.
So now, that is equal to y, and now that you have those common denominators, you remember back to 5th and 6th grade, all you have to do is the algebra with the numerators, right? Negative 5 plus 21 is 16. Okay? So there's my word pair. Now here's my argument to you. Okay, and I tried to be as friendly in the homework as possible by trying to eliminate as many of the nasty fractions as I could. Okay? So I want us to learn the process first and not get kind of stuck on the fraction stuff. The fraction stuff can't go away. We can't eliminate them completely. On the end of course exam, if you get work that involves fractions, don't let the fractions be what causes you to do poorly on that, right? I don't want arithmetic, adding, subtracting, multiplying, dividing, fraction work, to be what keeps us from being proficient on that test. Okay? So, I did some research. I've been telling you the last couple days that I wasn't certain on what they're going to give us on the end of course exam. The end of course exam gives us a version of Desmos, and I'll give you this URL so you can start getting used to it. There we go. So it doesn't, it gives me this. So this is going to be the calculator that's built into the test. Will be a button or a link that you can click it to open it up. Okay. There's a couple things that it doesn't do that Desmos' link on their website gives you. But this is pretty much what you're going to see. So my suggestion to you on that test, we'll see if this thing will, if I go negative 5, then I hit my divide key, which is the question mark. Okay, it's that / or backslash, I'm not sure which one you call it. And then 7. Then I'm going to go over to the side and hit plus 3. Okay. Oh, here's the thing. Is that fraction thing there? Nope. Okay. So this is the version that they're going to use. So I was hoping that it would be there, but it's not there, right? So I have to be able to add fractions then is what this is getting at. Okay. If you're on your homework or whatever and you're using this Desmos, see how I type that in and it gives me that decimal, right? But here we've got that button we can toggle back and forth. Okay. So be on the lookout for that. Be thoughtful of that as we're working towards that date. We've got, we're getting closer and closer. April 28th is that date that we take that test. If you struggle with fractions, hopefully now to then we start to get those things kind of fixed. So negative 16, or sorry, positive 16/7 is that solution. Is that all right? Okay. Let's do this one right here. Do it by yourselves. Okay.
What day's Friday?
Today's Friday.
I said what day?
It's 2 days from now. It's the day it comes after Thursday, right before Saturday. It's sandwiched between those. It's different this year, but.
Is it 31st?
Yes.
You guys think it's kind of amazing? It's already February.
It's not.
Well, we'll be Saturday.
Yeah.
We get through February and we're almost done.
I get my phone back in February.
So she can text that one boy again.
Thanks for the people on the other end of the
I
phone.
locked him on everything. It's a
Please don't
nice
check
guy.
mine.
What'd you get?
Yeah.
I can't say
Even my
because I
phone
don't
face
want
on
to.
her.
Why?
Because I want to make sure it's right. No, don't look at her.
I know. I think
Yeah,
I did
got
it
Yes,
right.
those are right.
Yeah.
Okay, good.
Why you got paper out, Richard?
Yep. Awesome. Looks like we're getting the hang of this. Okay,
Yeah.
so looking at these equations, which one already has something solved for?
Yeah.
Okay, so we know y is x plus 3, right? So right there, I can replace y with what?
You.
X plus 3. So I get 2x plus 2 times x plus 3 equals 38. Okay? Now as you set that up, you distribute, right? Here's the thing that I want to make sure we understand. If I didn't put my parentheses there, would you know that you're supposed to distribute? No. Okay, it just kind of runs everything together, right? Make sure you get your parentheses. And now when you distribute, you get 2x plus 6 equals 38, right? Now what? 4x plus 6 equals 38, right? Subtract 6.
And then you divide by 4 and
32. Yeah.
All right, so x is 8. Okay. Now, when I get x to be 8, which one of these equations is the easiest one to plug that back into? That one there. So y would be then 8 plus 3,
That's 11.
11. Now, here's my question. Just bear with me here. Let's say I didn't make that argument. Let's say I didn't recognize that it goes back in x plus 3 the easiest. If I go 2 times my x of 8 plus 2y equals 38. What's 2 times 8? 16 plus 2y equals 38. We'll subtract 16 from both sides. Does that give me 2y equals 22? Does y then equal 11? But you see all that extra work that is bypassed by making the, just foreshadow and say which equation is easier looking, which one's simpler. And then you save yourself a lot of work, right?
Yeah.
Okay. Now, as we work through and start to see some of these questions later on in the week, and early next week, we're going to have 2 equations that are like that top one. Okay, so we might, we do the 2 of them that way, and both of them are equally difficult to plug into, so you just choose one, it doesn't matter. And then you have to go through what's kind of in this bubble here. You want to do another one? Did we do example 3 in class yesterday?
No, we didn't. I don't have it written down.
Okay, so let's do it. I don't think we did either because I don't have anything written down, so I don't delete the notes. So I don't have anything written down here in it. One of the classes we did it. Okay, so there is anything solved for?
No.
No. Okay. But what variable up there and in what equation is a 1 something? The second one has a 1y in it, right? That's what we're going to, if they're not set up to where y is already solved for or x is already solved for,
I know what it is.
you're going to try to find the one equation that already has an x or a y that has a coefficient of 1. This is like not the hardest type problem because some questions, all of them might be non-1 values. Okay? But right now, we can see which one has that one. So what am I going to do next?
You change it.
I change it to what?
Y equals 2x minus 2. Is that right? I'm just guessing.
You're close. So you wanted to get the y by itself, right?
Yeah.
So how do I get this negative 2x to the other side?
Add it.
Add 2x. So I'm going to add 2x here. So I'm going to add 2x over here, right? Does that make sense to everybody?
Yeah.
So it goes away there.
Y equals 2 plus 2x.
So now I've transformed that bottom equation.
But now it's 2x minus 2. If you change it,
Huh?
change it again, it's 2x minus 2.
What do you mean change it?
Because it needs to be y, but then it's supposed to be.
Well, if I just jockey those around and write 2x, so just change their position, right?
Yeah.
It'd still be 2x plus 2.
Why?
Because when I move them, I have to move the signs that are with them. Because I'm moving on just on the right-hand side, right? They're not coming across the equals. If they come across the equal sign, then you change the sign.
Oh.
If they're staying on that same side, but you're going to move them around, you just move them with their sign. Now, it doesn't necessarily, so yes, this is different than y equals mx plus b. It's like y equals b plus mx, right? But that doesn't really matter when we substitute, okay? So just as long as your y is by itself, now I can come up to this equation, and where I see a y, what can I replace it with? 2 plus 2x. And then the pattern is, once you start doing this stuff, guys, hopefully you realize, regardless of what they give us, there's a lot of patterns to it. So you substitute, everything we've done so far, usually when we substitute, we then have to distribute. So 6 plus 6x plus 4x. And once we do that, we have to combine like terms, right? So there's my like terms. So I get 6 plus 10x equals 16. What am I going to do both sides now?
Minus 6.
Okay, so we get 10x equals 10.
And then 1.
And then x is 1. Okay? Now, what equation do you want to plug back into to find y? The last one, that bottom one, right? Okay. Now, is that the one we started with? No. No. Okay. But as we go through this problem, and whenever you change an equation, you are still allowed to, when you're done, use that equation to substitute. Because y equals 2 plus 2x is still the same thing as negative 2x plus y equals 2. Still produces the exact same graph. Okay? So when you are making a decision, well, which one of these do I substitute back into? You now have ultimately 3 choices. You can plug back into 3y plus 4x equals 16. You can plug back into negative 2x plus y equals 2. Or you can plug back into y equals 2 plus 2x. My hope is that you recognize that that one there, even though it's not the one you started with, is still easiest to plug back in because it still incorporates x and y, right? So you're going to hear me as we work through these throughout the next couple days. When you substitute, or you're going to go back and substitute for that last variable, you can do that to any equation in the problem that has an x and a y in it. Does that make sense? Okay. Would it make sense to substitute here into this equation? No, because it doesn't have an x and a y, right? Okay, and it won't tell me anything. We'll keep these special cases for tomorrow, but I do want to talk about one that's really easy, really quick. Middle one. It basically tells. So this is so simple that people get it wrong all the time because they're not thinking about what's going on here. Okay? Am I able to take this y being 3 and plug it into anything down here in this bottom one?
No.
Am I able to take x equaling 5 and plug it into anything in this top one?
No.
No. But let's talk about what is actually going on here. If I do y equals 3, doesn't that mean that the y value is always 3, right? So it's that line right there. Okay? Doesn't this one, if x equals 5, mean that equation? Okay? So this point right there, and this is that's the point we're looking for. The logic here is that the reason we call this x equals 5 is because no matter what point I choose on that blue line, what is the x value for every point on that blue line? 5. So isn't that one going to have an x value of 5? Okay. That point is also on this maroon line, right? What is every y value on that maroon line? 3. So isn't that point right there going to have a y value of 3? So Travis said, doesn't it basically tell us our answer? Yes, it does. When you are being told to look for the intersection of a vertical line and a horizontal line, you just take those numbers and make sure you put them in the right order for an ordered pair.
Yeah, I got so confused on the whole last night. That's why.
But do you see how now it's and I've I've made the mistake too. And when I was your age, it's almost like almost a trivial or very, we really don't have to do much math there. It's so simple the way it's structured that we think, well, I don't know what to do because it's different than anything else we've done. Okay, it's telling you what your x value has to be, telling you what your y value has to be. That's the point where those two lines are intersecting. Is that all right?
Yes, sir.
All right, so we're going to give you the next 15, 16, 17 minutes. You can work on 6-1. You can work on 6-2. Okay, but I want you working on either of those things. Some of you had questions about 6-1. You want to talk about those?
No, because I know what I did wrong.
Huh? Yes. If you had questions over 6-1, come see me, and I can work with you.